In today's video, I am going to simulate the equipartition of energy of a diatomic molecule using Python. Let's take a look on my simulation. The first simulation is a diatomic molecule with red atoms on the left and blue atoms on the right, which represent oxygen and carbon atom respectively. I have got printed result correctly as TA told. The second simulation is about the motion of 20 carbon monoxide molecules in a container. Their energies graph is on the right. Average kinetic energy of the center of mass in line green, vibrational kinetic energy in line red, vibrational potential energy in line purple and rotational kinetic energy in line blue. The theorem of equipartition of energy states that molecules in thermal equilibrium have the same average energy associated with each independent degree of freedom of their motion, and that the energy is half kT per molecule and half RT per mole, which K equals to Boltzmann's constant and R is the gas constant. The result of equipartition of energy is 3/2 kT. In the figure, we have 20 artificial molecules, each composed of 2 atoms. Red ball represents oxygen atom and blue ball represents carbon atom. They are connected by a bond which is represented by white cylinder. Each molecule has translational motion, vibrational motion and rotational motion. The translational motion of the center of mass of the molecule has 3 degrees of freedom, corresponding to motion in x, y, and z, and is associated with kinetic energy of the center of mass. The vibrational motion, which represented by red arrow, has 2 degrees of freedom and half of it, which 1 degree of freedom is associated with vibrational kinetic energy and another 1 degree of freedom is associated with vibrational potential energy. The rotational motion, which represented by the gray arrow has 2 degrees of freedom, corresponds to the 2 rotational motions with their axes perpendicular to the bond direction, and is associated with the rotational kinetic energy. For rotational motion, there are 2 degrees of freedom instead of 3 is because the rotation with the axis parallel to the bond direction is not discernible. I am going to show you my part of work instead of breaking down all the codes. Com is to return the position vector of the center of the mass of the molecule. Com V is to return the velocity vector of the center of mass. Vp is to return the potential energy stored in the bond similar to the potential energy stored in a spring. Vk is to return the kinetic energy associated to the 2 atoms' motion relative to the center of mass and parallel to the bond axis. Rk is to return the kinetic energy associated to the 2 atoms' motion relative to the center of mass and perpendicular to the bond axis. Comk is to return of kinetic energy of the center of mass. In the second part of the homework, my part of work is to complete the codes inside the while loop. I am to calculate sum of the energies and plotting the energies graph. The ratio of average center of mass of kinetic energy to average vibrational energy to average vibrational potential energy to average rotational kinetic energy is about 3 to 1 to 1 to 2, which are lines green, red, purple and blue respectively.